HITRAN database is special water vapor. Use the theoretical developed tools. The talk covers these topics. And the first three sections, I think, is the background. I assume all the people know that I very quickly. Then I go to the HITRAN database and how to improve HITRAN database and how to the screen results. Some slide I copied from the website. This is a copy website. This is about the radiation for the sun and the Earth atomic spectrum. I think everybody knows. Depends on the temperatures. The sun temperature is much higher. There emits a lot of much more flux, and the Earth temperature is much lower. Therefore, much smaller. I think this is the main features for the sun and Earth radiation. I think everybody knows. And it depends the temperature, surface temperatures. And the total energy flux is the horsepower of the temperatures. And also the maximum switch to the, if the temperature high, the maximum switch to the short wavelengths. I think everybody knows. What's the atmosphere? There are molecules. The most important one, nitrogen, oxygen, and so on. And also some molecules very important for the water vapor, CO2, and ozone, and so on. It's greenhouse gas, very important. For example, water vapor is very important, although they not account too many, but it's very important, and also varies depend time and regions. These molecules are very important. Therefore, the next section is about molecular absorptions. Why molecular absorption radiation? We have to understand the molecular energy levels. The molecule have the three kinds of motions. One is called electronic motion, another called vibration motion, and the rotational motion. For each motion, have different energy levels. For the electric motion, very high energy associated. For vibration motion, is next. For the rotation motion, energy much lower. For the infrared radiation, energy comparable for the radiation, for the rotation energy. Why molecular absorption radiation? Because they can absorb photon energy, jump from the low state to the high state. The photon energy must match exactly with energy gain. And when you absorb molecules, the absorption line is something like that. And it depends this energy level, jump energy levels, and also intensities. The different jump have different intensities. This is for if a molecule, also isolated molecule, absorbs the radiation, something like that. But in reality, the line not some like delta function. This looks like delta function, but the reality is not delta function. There we have to talk the line shape. And the line is not a delta function, become broadening. There are three mechanisms that cause the broadening. One is the natural broadening. The mechanism that has Heisenberg uncertainty principles. The line shape is Lorentzian. And this is independent of temperature and the pressure, is independent. Another is Doppler broadening. The reason is that the mechanism is molecular motion, thermal motions. Therefore, their energy, the line shape is not that function. The line shape is Gaussian. And the half-Venus is proportion, something formula that is. Another important phenomenon is pressure broadening because the molecular interaction with other molecules, therefore, line shape changes. The line shape in the case is Lorentzian. This called half-Venus, and this called shift. And this is line positions. And the half-Venus and the shift, the proportion, the pressures, and also dependent temperatures. For the shift, how to depend temperature, we have not at the stage considered how to depend temperatures. We will at the stage consider half-Venus dependent temperatures. This is an empirical formula. empirical formulas. And these numbers m called temperature exponent or temperature variation coefficient or temperature independent coefficient, sometimes called temperature exponent. This is index m. These formulas, empirical formula, is not varied within 13 temperature regions. These empirical formulas. This is the Planck Brownian. Therefore, we know that three mechanisms. For the natural Brownian is not important. We don't need to consider it in general. For the Planck Brownian, very important, very important. And the Doppler Brownian sometimes we have to also have to consider. When both the Doppler Brownian and the Planck Brownian have to be considered, this line shape is called Voigt line shape. This line shape is given from these formulations. Usually, line shape, the f function is normalized. Each one is normalized. This picture shows if the non-Brownian's line shape is delta functions, and if the Brownian line change become the winders. Because the line shape we usually assume the normalized, therefore this area, integration area should be the same thing. This integration should be match with photointensities. And also the pressure increase, line becomes wider and wider. This formula is called line by line calculations. Absolute coefficient, how to calculate line by line calculations. Using K dependent different about gases. What kind of species of atmosphere molecules? For each molecules, the formulation will summarize this. F stands for final states, I stands for initial states. This Fi means each line. This is intensity, line intensity, and the positions. And this called line shape function, usually normalized. It's normalized. Integration over omega equals 1. This for different molecules, important greenhouse gas molecular absorption in the atmosphere. I think so far everybody knows this is common use. Because of radiation, we have to consider all the molecules in the atmosphere and also all the spectral parameters. Therefore, the database is very important. This database, most important database, a lot of database, but the most widely used is called the HITRAN. Before picture something like that, called the HITRAN. Where is the HITRAN come from? Here. This is about HITRAN starting HITRAN about 50 years ago, more than 50 years ago. So many people, so many laboratories made contributions. Therefore, right now, this the most updated version, 2012. How many lines included? About 7 million lines, and cover 47 molecules and a lot. Incorporate isotopologues. And besides the HITRAN, there are new one appeared called high temperatures, high temperature. This one want to meet atmosphere, planetary atmosphere application because the temperature much high. For the HITRAN, for the Earth's atmosphere, the temperature much low. For the high temperature, this database, we have to include many more lines because a lot of lines excited at high temperatures. This is just the beginning. This is just the beginning, including much more lines. And there are other database. Some database surprising how many lines. Some database including 500 million lines altogether. Such huge numbers. And about the qualities, I think the HITRAN better than here. Because this is new development and including so many lines, therefore the quality not very good. But the HITRAN, because it's 50 years effort. Every 7 weeks, the conference, HITRAN conference, the HITRAN database runs something like this, all the contribution volunteer made contributions, and the HITRAN itself did not have the money. And all the people get the free ride. HITRAN data was free, but nobody, not any special financial support for HITRAN. All the people had the volunteer contributions. This is caused a big problem.
Are the wavelength ranges the same for the two databases?
Again?
Are the wavelength coverage the same for the two databases?
Not the same.
No, they are the same.
Which one?
Are the HITRAN and HITEM
Not the same.
databases?
Not the same. Not the same.
So what are the coverage ranges?
I think that this is more this is more covered more, much more. This is new development. Just show up recently and not complete. The only line assignment and the position. I think that have been shifted and not.
But what is the range?
Wavelengths, I don't know. Okay, much more. It also depend molecules. This one to cover is very cover the application. If you some applications they have covered, they meet the user applications. And also increasing induced absorption, and also they're trying to add a new database. But probably the same no financial support. All people contribution volunteer. Therefore quality not guaranteed. This is a copy from the website. Losman, the person in charge of HITRAN database. And from his data, this is 2 atom molecules, 3 atom molecules, and so on, and molecules. This is most of the update for the 2012. The current version, every four years, get the new versions. The current version 2 years ago, 2012. The previous version, 2008. And each the new version covered, added more lines, are covered by the regions. This is 3 important molecules, first 3 important molecules. In the HITRAN database, what is number 1? What molecule is number 1? And what looks like such a HITRAN database. For each line, including 160 characters. These first 2 were identical molecules. As I mentioned before, what molecule number 1? CO2 number 2. And also there are 6 parameters they called spectral parameters, 6 parameters I typed by red. One is the line positions, what to look at locations, intensities, air Brownian heavies, cell Brownian heavies. What means cell Brownian? Cell Brownian is water Brownian, water vapor Brownian by water vapor. The air Brownian may contributed by nitrogen Brownian and also include the oxygen Brownian. They are combined together, air Brownian. And the temperature exponent is how to have ins vary with temperatures because and also provide shift. This is 6 parameters, spectral parameters. When you run the code, radiation code, you have to use these 6 parameters sometimes. And also, these quantum numbers use identify initial states and final states. This is labeled lines. This is used to label lines. And also, this one important. Most time people forgot, not pay attention. This is called uncertainty estimate. By the people in charge of the database, they estimate uncertainties. Because my talk is about the uncertainties, I will focus on this next. The HITRAN have tremendous contributions, 50 years, and very important widely used approach. I did not say here his big contribution. I just emphasize the uncertainty, his progress there. This uncertainty, the current situations. For line position, excellent. For the pure rotation band, the new versions I check their uncertainty index. I found 90% with these images, 90%, and 80% in images. Therefore, in most time, very accuracy. For the lines change, I checked with still also for the pure and bad. This is they claimed from their database they claimed 67% is 5 to 10% error uncertainties, and 33% is 10 to 20 errors uncertainties. I think it's good. My estimate, I think for it looks like it's better than estimate. It's better, not such bad. It's better than what he said. For airborne, you have is also for the pure and bad, what they say, 60% to 5-10%, and 10 to 20% remaining, almost remaining. I said reasonably good. My estimate is their estimate. My estimate is different from their estimate. My estimate is if heavens is larger, quality is good. If heavens is small, the quality is poor. I can explain why, but I'm not time here to explain. In general, I don't believe that 60%. I don't believe it's less. It is less. For self-running, not good. And also, I have no time to explain why not good. I can explain from experiment and also from the theory. I not why this is poor and this I can explain, but not time. They say 88% from average estimation. They did not provide a detail what kind of estimate because they're not sure. They're not sure. They say this data from estimation of the average. For temperature exponent, my state claim poor, but they say something like that. Really, of course, this is must be poor than this, because this temperature tendency come from here. If they calculate or measure different temperature, then fit the formulas, get the index poor, because measurement in a different temperature, especially high temperature, very difficult, because they have, especially the low temperature, very difficult, because the reason there are few water vapors in the tubes, very few, very difficult to measure. Therefore, this quality mostly from the theoretic calculations. The theoretic calculation have problems. Therefore, this also have problems. It's not good, not as estimated. For the induced shift, is very poor. It's very poor.
The accuracies here, does this apply to the CO2 also, just for
this water vapor?
Just water vapor.
I also talk water vapor.
So are these like individual satellite retrievals, or what makes up each one of these lines in the database? Like, is it a measurement in a laboratory? What exactly is each line made of?
What do you mean?
Are these ab initio calculations, or are these actual observations from a laboratory?
This one combined. Most line position. You mean line positions?
Well, you said that like there's 7 million.
Yeah.
points.
This is maybe
Each
for
one? What is
all the molecules. What vapor not so many.
So what is each line? What is each line, a satellite retrieval or a laboratory?
Most
experiment?
is theoretical calculations.
So they're ab initio.
For the line position, especially line positions and intensive most come from theoretical calculus. The situation is here. In molecular is isolated molecular qualities, quality is good. If involved interaction is poor. For line position intensity is isolated molecules. For other qualities, due to interaction, become poor. This is easy to understand because we do not know interaction very well. For isolated molecules, all the depend on the points we have a good knowledge of. Like for line positions, very accurate. Intensity it is better, but for the remaining poor. For the induced shift, very poor. And also there's some errors. Intensity units, their dimension is not wave numbers. They also depend potentials, atmosphere. For per atmosphere, wave numbers. Therefore, their intensity, their errors in this case, we cannot use this. Use this to estimate their uncertainties. I talk about the four. I have just said the four is not good. All the parameters involve interaction is not very good. Why is not the reason how to improve that we have almost spent 50 years to improve, but still have not achieved the goals. It cannot meet the environment. I have read the paper. It said for the short lines they want to have this 5% error uncertainty. No, 3% error uncertainties. For the weak lines, we want to 5% error uncertainties. We cannot achieve this. And also, I read some paper said that 5% difference in wavelengths will cause big difference in retrieval or something. It cannot meet the user's requirement. The real measurement is very difficult. Measurement is not difficult, and there are too many lines we cannot measure. So many lines we cannot measure. And therefore have to rely on the series calculations. The series for quantum mechanics, they're called close coupling calculations developed by Qiancheng here. Unfortunately, he passed away in 1995. Sunday he passed away when he's 50. He's just like my age. After he passed away, his postdoc left, and all the code, Morse code stopped. Right now, Morse code, this code is most used by widely used people, calculate heavies and shift and so on, but only for linear molecules. Qiancheng trying to calculate water and hydrogen. He tried to cover more and more computer system, but when he reached the water and hydrogen, he passed away.79 this stopped, not any progress. For the semi-classical series, is most of the series about 1979, almost 30 years ago. And this series, semi-class series, contains several weaknesses. I mean several approximations. They are not good, sometimes not applicable. Therefore, they are not good. But right now, this series used calculation provide a lot of series calculations because not any choice. This is not impossible for water molecules. At least for linear molecules, this method can calculate. We use the same potential calculator for the accurate and compare semi-classical method, compare linear molecules. This is semi-classical theory is poor. How poor? For the nitrogen Raman Q lines, semi-classical theories of estimate heavies 40%. 40%. For the water, not so bad, not such bad. For the linear molecules, most cases 30%, 40% mistake. Therefore, this is not in any solutions. We have to move, try to develop better versions. It's difficult. I'm working on this subject and made some progress, but have not solved all the problems. Another method, empirical models. This is more widely used because although calculation available, but still cost a lot of time. But the most data from the empirical formulas. Empirical formulas because they have not any physical guide to what kind of formula looks like. Therefore, not reliable. These three problems, this is stopped. This made some progress, but not too much. Still have big problem there. This we don't know what happened. This situation, any change? Not near future. this current situation. the main reason is no resources, the hash database, no resources. How to solve problems, find a way, we have to find ways. I think about problems and trying to find simplest way to solve problems. I think when solutions trying to understand why and how the spectral parameters are very visualized, understand these fundamental physics problems, why spectral parameters very visualized and how to visualize. My solution is that I consider all the system as black box. The system including what absorbed molecules and the space molecules are radiation field, consider a system as a black box. We don't know what happens inside. We don't know what happens inside. This inside it means theoretic calculation or the measurement. We don't know what happened. But only we interested in input and output. The input, what input? Input the line of interest. What the output? Output their spectral parameters. We try to the input, find from input, link some output. This idea. We don't know what happened inside, or we are not interested right now. The real reason is we don't know what happens. Main assumption, we assume this system is stable, not strange behavior, it's stable. Therefore, three assumptions. Output depend input. Output depend input. Identical output, identical input yield identical output. Similar input yield similar output. These three assumptions, I believe, reasonable. What is the input right now? The input, the lines of interest. For the quantum mechanics, it means their energy levels, wave function of their initial states and the final states. This is input. Energy levels and wave functions, their initial states and the final states. This is the input. I try to find their identity, similarity, the input. If I can find the similarity in the input, I believe their output, their similarities. This is my idea. Therefore, I look at from energy levels and wave function for the states, not for light, for the states. I find there really have identity similarities. We can divide the lines, divide states into the A type or C type. This is states, molecular state, J and K and KC quantum numbers. Sometimes the K numbers close to J, we call it A type. If KC close to J, I call C type. This depends on some similar molecule is unsymmetric top. I found for the A state, if the two states like this delta, it means the small numbers A delta equals 0, 1, 2, and 3 or 1. The two states in A type is paired. These states have almost identical energy levels. Therefore, we can categorize if these pairs in the groups labeled by delta. All the states with the same delta and with different J go into the groups, into the same groups. We can find the features. The pair states have almost identical energy levels, and also in the same group, the energy level very smoothly.
So can you quantify what you mean by identical? Almost identical?
Almost, not exactly. Almost identical. I talk later.
Okay.
Same thing happened for the wave numbers. wave numbers because these unsymmetrical wave numbers of wave functions, their wave functions in terms of something like that. The expansion of this symmetric wave function. Therefore, wave numbers depend by this coefficient. The main feature again, the coefficient of two pair states with high J values all have almost identical magnitude, not always identical value, but magnitude identical. And the patterns in the same groups with different J change move smoothly, very smoothly. Just this is my state. I'm sure the fingers. This is what energy levels. When it's A type, this is A type, this is C type, and this number means the data, and this numbers means the level of groups. For example, the group for the C type group is 1, group 0, something like that. A type group 1, something like that. Look at each their double overlap. They are two simple overlap. This means the energy levels, almost the pairwise energy levels, are identical. Look at, not very clearly, always the two simple overlap.
Well, it's hard to tell because your energy level scale is centimeter per
Because this
centimeter,
is
and you're using huge numbers there.
Yeah, of course, it's huge numbers.
And before you get errors of 0.001s.
Because they are.
So it's hard to tell how close they are in this plot.
Otherwise, you cannot show because of the wide ranges. Because the scale is too large, you cannot use smaller. You cannot.
So how close are they actually?
We'll see later.
Okay. You keep telling me later.
Yeah, just later. No, just later. This is wave function look like. This is A type wave function. This is the first group, the second group, and from the different J. For this side, these two groups, two pairs, almost identical. For this left side is a mirror image. They become mirror image. Therefore, I say the magnitude identical. I have not said the value identical. Magnitude identical. This is the first group, and the second group, and the third group. This is A type. And also look at for the different J. This J is 3. This J is 6. For different J, vary the pattern similarities, very similarities. This is C type, group 1, group 2, and group 3. And also pay attention. From here, I started from 7. From A type, I started from 3. Why the difference? I'm sure. I say the identical is not exactly. We have some tolerance. We have some accuracy tolerance, we say. How to measure the identity tolerance? I introduced the parameter so defined by the relative difference. This relative difference epsilon depends J. If the J is high, become more identical. If J is small, become less identical. From different J, the epsilon changed. If you assume the 1% error, around 1% error, everything around 1% error, I calculate for this for the J3, something like that. So, therefore, I can determine if for the 7, if the J above 7 is good, the identical and smooth variation you hold. It's less 7, you broken down. This is a method. And look at for A type, for the J equals 3, begin from J equals 3, almost identical. The high J is better. The rule holds strong. Why this happened? We can look at Hamiltonians. See, I'm not trying to explain why. Basically, they're Hamiltonian. These are isolated molecules. Therefore, I already know how to characterize the states. Therefore, next step is to categorize lines. The categorize is much easier because we know how to categorize states. You both consider initial state and final state combined together. We know how to categorize line into the groups. I just compare all the lines and the societies, each line and members. The society consisted by families, I found. Each family is there our family members, the family members, or the twins, two twin brothers. And each family members, the face looks like same. It's something like that. But the problem is how to identify families. This is how to identify families. We identify families from the initial states and in the final states. Therefore, we can calculate. I will show you how to categorize the lines into different groups. Their formulas. I'll show you later. After finish complete categorizations, we define individual groups or also called families. Each lines, their input and output have similarities, identity features. Therefore, one should expect the output has similarity, identity features too. Therefore, the two rules established. One is called identical rule, pair identical rules. Another called smooth variation rules. What are the pair identity rule? It says to pair the lines whose J values above certain boundaries have almost identical spectroparameters. Almost identical spectroparameters. Why they are identical spectroparameters? Because their input is the same. Their output should be the same, very similar. And the smooth variation rules for different pairs in the same group, their values, spectral values vary smoothly. Why very smoothly? Because their input very smoothly. These are two rules. This rule not exactly is certain uncertainties tolerance. I just say if they allowed 1% error, the boundary I calculate about this boundary, about 30 boundaries, the rule hold. Usually the second rule hold early. The second rule, smooth variation, hold early than pair identical rules. These are the rules. By screening all the database with the rules, we can identify errors. If some data did not outside these outer lines, this means something wrong. There's something wrong. Therefore, we don't need any resources. We just use current database. We can improve by pick errors. By pick this, remove these errors, the accuracy can be improved. This is how to categorize details into families. From different bands have different formulas. This I have not time to go to details. This is another different band, another formulas. And what kind of results? For this, for 2008, all this band, pure band, and the first vibration band, this number is 960, so these 9 lines. And all P branch 207, Q branch 544, and R branch 888. For each group, each branch, the families. The group means families, a lot of families. You divide these numbers, divide by each, some group there are only few numbers. Why there are few numbers? Because the cutoff. Because the database there's some cutoff. The high GISS states intensity is not very weak. They cannot include. If they included, this very numbers increase. It's cut off. Especially high GISS states cut off. It did not include.
So how high are those GISS states?
Okay.
How high did the cutoff go?
their cutoff depends the threshold. I show you later. And usually 20 something G or 20 something, 20 or something. And the high temperature database is much higher, as you could be 40 something. Begin they might begin screen. I screen 6 parameters for line positions. Very good. Look at it. Very good. This is not strange. This is not surprise because this edge levels, line position subtract the different edge levels. Of course, it's good. Okay, look at all the very smoothly begin here become merged. After this merged, these boundaries. These boundaries. After the boundaries merged. After the boundary merged. Before boundaries almost steers very smoothly. This is not surprising, it's easy because for the line positions, the tool cannot identify errors now. We cannot. We only 1% accuracy. We cannot identify because his accuracy much higher. But we can identify some mislabeling lines. If the line mislabeling, the code numbers line in wrong, we can identify. This is intensities. The results not clear. Show up. The figure. For our line, our branch, look at. This is completely wrong. And this is completely wrong. And this is questionable. And here, something like that, not good. These numbers completely wrong. And this number is this number completely wrong. And this number is completely wrong. This number is completely wrong. And this is completely wrong. We know this is wrong. And also look at this scale, log scale. Therefore, this mistake, the error, big errors, because this scale is a log scale. It's just one order mistake. This is a Q-balance, similar. This is go wrong. This is not correct. This is not correct. This is not correct. This is terrible. And this is terrible. And this is not terrible. Terrible. The mistake is not several, 1 or 2 order mistake. This P branch, the same thing, similar things. This is completely wrong. It is completely wrong. This is completely wrong. This error is not 2 times, several order difference. Therefore, for the intensity, we can improve some big error. You can tell them your measurement is wrong. This is for airborne. You have airborne. You have means. We look at this is wrong. They not overlap, not identical, and also not change smoothly. This is wrong. Not identical. This should be identical. This should be identical, and not here jump from one point to another point. This is completely wrong. This is completely wrong, and this is completely wrong. This is completely wrong. We know that. This is Laboratories also happened. The same thing happened. Not good. Okay. Jump here. Jump here. Jumped. They suppose it should be there. When you check the outliers or some mistake, you have to keep your mind. The rule is after boundaries. After the boundaries, if the GL law state, if you find this different gap, just skip it. The rule cannot say anything about it. If the GA high after the boundary, Sure, it's wrong. The important thing is the molecular spectral molecules is become poor for the high GISS states. In more high GISS states, the quality become poor. But the rules at that time become more powerful. This temperature experiment, it's not too bad, but still some problems. Why not too bad? Why not? Why not? It looks not too bad. Why not? Why? Really? Because this result from the calculations. I will show you later why series cannot, if series calculation cannot cause some problems. The reality is not just shown by here. It's here show is good, pretty good. The reason is theory calculation is not correct. This is a big problem for shift. I emphasize for the shift. But here, it's confusing because I have two figures together. One is from the database 2008. This is by the red and the green, not very clear. Red and green symbols is from the database. For example, here. This is not very clear. Red and green symbols for the calculations from the database. Jumped from here, jumped from here, jumped from here. They did not certify identical rules and not certify smooth variation rules. And also I calculate, because this data, these values from their calculations, I use the same potential, I calculate. This is my calculations. This is my calculations. Look at my calculated results very smoothly. Look at smoothly. Also identical, smoothly identical. My calculated results. This is 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 my calculated results. Use the same potential. There's a big difference there. My calculation follow the rules. Their calculation did not follow the rules. This data for the shift, this data from theoretic calculation, semi-cluster method. How to explain? My comments. I made a comment two years ago, more than 2 years ago, when I finished these studies. I told the person who is charged for this database, I told him you made serious mistakes. The two rules derived from the property energy levels and well functions. Therefore, all spectral parameters involve high GISS states must follow the rule. No matter this data comes from the measurement or theory calculation, must follow. For theoretic calculations, unless you make a mistake where in derived energy levels and well functions, and also made fatal mistake. Your theory inconsistent made. For example, your code have bugs. Any theory calculation must automatically follow the rule, because this comes from black box series. We don't need to know inside what happens. The only requirement that your calculation is consistent. If your theory is not correct, but you are consistent, your result follows the rule. But in this case, your result did not follow the rule. What it means? What it means? It means here. The formulas contain fatal mistakes. Not any excuse. I told the person who is charged this, I told him, you made fatal mistakes, come here, with GISS. And I told him, you made mistake. I can help you to fix. I send my code to him. He had to go back. Oh, just a moment. What outcome? After after I made the comments 2 years ago, the new version almost changed, replaced, because they know they made fatal mistake. All the shift data have to be replaced. And also, for the temperature exponent, I say it looks good. That means good. That not means good, because theory calculation must automatically follow. We also can identify missing lines. Some line missing, not complete. Some missing, we can find it. This is intensity for the pure ozone band. Of course, this is completely wrong. I keep in mind this is completely wrong. And also these two points should be like this. And also this star point I predict but not included. And I predict they missing here. And the missing lines, some missing lines. For example, for these groups, for the much weaker lines they are included, but this one is missing. Therefore, we can we can say some line missing. And this is estimate, my estimate from all this data, estimate. This is, I found for the pure ozone band, the 81 lines missing. This is the triangles missing line collisions. And this one, they include, I say the previous one, big mistake here. This one. Here. Look at this one, pay attention here. Now, this is threshold. Suppose if the intensity below, we did not include this database, above included. But still, there's some lines, 81 lines missing. Any conclusions? The fundamental question I have answered. Why is spectral parameter value with a line? Because they input, output. They're different line have different energy levels and wave function. Therefore, they are varied with the lines. How to various the conclusion here. We see individual defined groups, variations, spectral parameter can very well monitor. We can predict it. We can understand how the variations is either two rules, pair identity rules, smooth variation rules. The two rules have two characters. One is natural. Natural means they come from energy levels, wave function from basic quantum mechanics. And also local. Local means they vary in the within groups. From different line in different groups it cannot be applied. And also varied above for line above certain boundaries. For the logical states, the transition did not work. I already tell you what the boundary it is. Therefore, by screening all the database, we can identify mistakes and provide more reliable data. Additional, some missing line, we can find it. Therefore, we can use the current resources. We don't need more research. Current resource, just the database, we can improve the accuracy. Most by picking of the errors. This idea very simple, very general, and also can apply other molecules interested in the modern field. Fish.
Who uses the HITRAN database, and have these errors you identified been propagated elsewhere?
Who uses the database?
Who uses, like, are the lines in the database used, like, when you do have a satellite retrieval and you interpret that and you have a certain chemistry in the atmosphere? Is that influenced by, I mean, are they outside this database?
I think the problem lies the database is when you remote sensing or called GCM models, a lot different components involved, aerosols or something like that. This molecular absorption only part of them. Sometimes people did not tune here, tune there, therefore did not show. I'm not very familiar with the applications.
All these errors have been fully incorporated into the Model E radiation code.
Oh, okay.
So can you translate the language of your plots into what portion of the spectrum was affected? Was it the entire spectrum? Was it the water vapor continuum? Was it the window region would be most affected by this?
I think it's probably harder to say as I mean, whatever the calculations in Model E are, what in terms of percents, how far off is it? Is it absorbing too much or not enough? That's much harder to say, but errors are scattered all over the spectrum.
So,
But one would imagine that the effect on a climate model would be greatest in the portion of the spectrum with the least opacity. So
Yeah, I don't know. I guess my feeling or hope is that I don't think these errors are significant compared to all other problems that may exist in the radiation or the GCM. But there's, I mean, if you're doing remote sensing spectroscopy in these specific areas, then you have to be more careful there. Because that, hit a spot where you have error, you can get wrong results.
If they were going to have an effect, it would be somewhere like the dirty window, as at 20 microns, right? Because you can see through to the surface in polar regions, but there are lines there. So if you have a line that's not actually in the database, that can actually have an effect, whereas elsewhere, if you're in saturated areas, that's not going to really affect you. So if there are new lines or misassignment of lines, it would be the dirty window that would be the obvious place to look for a significant radiative effect.
So Valdo, my understanding is that when you made the latest version of the correction factor lookup tables, you were using the HITRAN 2012.
Yes.
So I imagine you were able to quantify the effect of switching.
It's hard to say. The assumption is that you have compensating errors. In other words, you have errors all over the place. Hopefully that errors in the positive direction compensate in the negative direction. It's hard to say.
Yeah, so that's one advantage, I guess, in GSM radiation. It's like the model only cares about the net integrated heat and cooling effect in there. So if you have plus errors here, minus errors there, they get averaged out, so more or less.
I think this is the current situations. I think people usually did not pay attention. They usually assume the Hydra database and something very perfect, but not the case. You have to keep your mind.
But we've been updating the radiation every time HITRAN, every few years they come out with a new version, so we include it, and so you can look at the differences between the different versions, and so in some specific spectral regions, they could be an order of magnitude different, but when you integrate over the whole spectrum, in terms of effects on heating or cooling rates, it's hardly noticeable.
Not all.
So this,
not all
you
true.
updated from 2008 to 2012, and there's not that much of an impact.
I don't think there's that much difference.
No. There was a problem about a decade ago to water vapor lines in the near infrared. So it was pretty far off. And some news and that was presumably better.
That was then you were talking about 10, 15%, 20% type of things in some of these near infrared radiation bands. In there, that was
like 10 years ago.
20 years ago or more in there, and that led to various spectroscopists almost coming to blows in various conferences, and data screwed up and all, whatever. think you have the theoretical models that give you all the lines in there, then they have kind of more broader bands, you know, measurements, so you can kind of normalize everything to make sure that it's, gives kind of the average results, and that's kind of the normalization coefficients. Getting absolute numbers is very difficult, in there, so you're sort of always looking to see if the whole thing hangs together.
Not always true. The updated version is better than pre-version. Not always true.
Yeah.
The Roseman told me the 100 waves, the progress just look like go ahead 2 steps, 1 step back. Just like that. For the water case, water vapor case, 2008 is very poor. 2008 is poor than 2000.
So have these screening rules, have these been applied to their new high temp television?
The problem is I just say the HITRAN, they know resources. Only the newsman is the charge, and also his editor, JQRST, is very busy. He has an assistant. Right now, they are trying to add more molecules. They are high probabilities, and also including the clean-induced absorption and high temperature case. They're not any energy of resource to improve. And also this they did not responsible for individualized contribution, volunteer. Come from the volunteer contribution, they're not responsibilities. This situation. Roseman complained that this is a free ride, but nobody support. He said NASA is good, previously NASA is good. NASA provide a lot of support. Right now, funding is no fundings, even for the NASA. About 20 years ago, something, more than 15 years ago, something Roseman, he said, sometimes I have no money, I go to Washington DC to ask Air Force. Also, some DOE or something, NASA gets some funding. Right now, no way.
So NIST doesn't give any funding for this?
NIST?
Yeah.
No, not below NIST.
I thought that NIST was paying for
No,
some.
not any aviation for NIST.
Not what?
NIST. You mean NIST, NIS, stand, not any relationship. Previously, the hydrogen was developed by Air Force Lab. In the Boston Air Force Lab, they have a big group there. I don't know what happened about 15 years ago, something. Roseman, only one person left towards this lab, go to Harvard Smithsonian. Customer centers, only one person left. But also he brings the HITRAN with him, only one person. He left the connection with the Air Force structure there. I don't know what happened inside politics. But after that, every contribution will become volunteer.
A really naive question. I'm just wondering whether the increase in, computational capacity in general is able to help with any brute force methods to
I cannot hear.
because the increases in computational power, supercomputers and the like, one would naively think that these could help with brute force techniques to fill out databases and so forth and so forth.
You mean
I don't know anything about the subject.
increase the computer power. I think for quantum calculation, if Shane is still alive, would he still alive? The problem much better because almost 15 over 20 years passed away, 18 years passed away after he passed away. The computer power much improved until he stopped here.
But the computational chemists are still moving forward.
After he left, his brother Philip left because now found his end. When he last years I joined with him, we write a proposal trying to cooperate with him. When proposal submitted, he passed away. They rejected because the PI is gone. The PI is gone.
I know for the oxygen A band at 760 nanometers, they they changed so they're not using the Voigt profile anymore, but they're using some more sophisticated profile.
Okay.
For the oxygen A band,
Auction.
yes,
Okay.
they're not using the Voigt profile anymore. They changed to another profile. Do you know anything about it? And
I don't familiar with auction. I already most focus
Oh,
on
yeah.
water.
yeah.
First of all, the water vapor, because my story is a research story. I first interested in water vapor continuous. This is window continuous. This is we have the line shape in the far winds. When I try to understand, because I found how to connect with the line in the center and the line in the winds, we have to smooth connect. Therefore, I try to understand what happens for the line centers. This means Roman shapes. When I was studied, I found I have impressions. All the theory is good. I think the theory is good, but I look at not the case. It's not the case. Especially for semiconductor theory. Semiconductor theories, when used, there are a lot of problems there. Therefore, I changed my research subject, go to the calculate line shapes, and for the semiconductor series. I have made some progress, but I have not solved it.
So have you looked at the CO2 lines? These do the rules are the CO2 lines any good?
Have not the times, and for the water vapor the situation says. Oh, I have left the water vapor almost 10 years ago. I have not studied. I changed my subject, go to the line centers because I found a problem there. After I left this field, and also in the United States, the people doing line water vapor continue almost out of business. The reason I found this. Therefore, the study progress in the water vapor continues in the United States almost stopped. 10 years. Then, at the same time, the British and the Russia get progress. They have big problems. Therefore, for recent years, they proposed the dynamo series. They say the water vapor continues from dynamo contributions. They very equitably propose their ideas, and there are a lot of conference held in the Europeans, and for the people in America, we have no money go there. We stay outside, look at what happens. And recently they say, they claim, especially in British English, the groups, the big groups, they say Tony Croft models. Most use the Tony Croft water vapor continuum models. They're completely wrong. How wrong? 2 or 3 order mistake. When I study the water vapor continuum, I always argue with Tony Croft. I say, I calculate with different from you about 20%, 30% like that. I say, I do not agree with you. We argue each other. Right now, I found they criticize Tony Croft 2 or 3 order difference.
Tony Croft's models are also compared to observations. They're empirical, and took also on a thing.
Therefore, although I did not agree with or completely agree with I defend right now defend Tony Croft. I say it's not impossible for the Tony Croft continuum model for each Windows. They have 2 or 3 orders, big difference. It's not impossible because they come from checked by applications. But we keep the silence. We did not nobody to do any issue. Fortunately, recently the French group made a new management. And the first paper published JQRST. Their management about 5,000 web numbers. They support Tony Croft's models and did completely different from the dynamo contributions. And recently they another paper submitted GGR. Just published this month, online this month. They made a temperature patterns. They also did not agree with dynamo models. They say their measurement differ with the dynamo, their dynamo groups claim 2 order difference. this is kind of situation. And also, some people say use the dimer continue contribution, use the GC and predict something, and also the big difference publish GHO. Therefore, in a society become confusing. What happens? Nobody knows. This is whatever continues in the progress. The problem is that I think that the complaint in the United States, the basic research not supported. When the first cut budget basic research, there are not any resources that can submit proposals. I tried to submit my proposal for the advanced compositions. I submitted my proposal just present this year here, and the manager told me you are not suit my proposal. Waited. You're not suit for this current announcement. You have to wait. I waited last year. Not appear this year. No. Therefore, if for the GC, I understand for the remote sensing of GC models, you build up huge buildings, but you have to make sure each brick is correct. This is basic research, just to make sure the bricks is correct. Otherwise, huge buildings